Hey guys, you probably have this in front of you. This is your additional examples for 4.3 and 4.4. So we're going to get started here. The first one, go ahead and if you want to pause the video, you guys can read it. And when you're done, you can come on back. Hopefully you've read the problem now, and so you're kind of getting an idea. You've got two cell phones plans here, and we're trying to figure out where the break-even line is. And so what we have is this chart that we are going to be filling out. Let me get my pen here. And we have some values, and then we have the blanks that we need to figure out. So we have the flash, put an F for flash, and the horizon. So we first have these formulas that are underneath both the flash and the horizon, which is a pretty nice deal. All we need to do is plug in the minutes to find out where we are going to break even. So to do this one, I always tell kids to start with one, fill out the whole entire plan, and then go to the other one and then see where it breaks even. So we start with our 0, and for our flash and for our horizon. And obviously for the flash it's going to be $65 there, so that works out easy. Then we jump to 50. So what we're going to do is we're just going to plug in the value of X for the number of minutes. So you're going to do 3 cents times the 50 text messages, and then you add in your $65, and it actually gets to be $66.50. So just continue filling in filling in the flash cellular price, and as you start filling it in, you might also start filling in horizons, and you'll see where it becomes equal to. So go ahead and start doing that. I can do one more example here. So we've got, the next one is 150. And for 150 minutes times your 3 cents, plus your 65 is going to be $69.50. So just keep filling it in, plug and chug, and see where it gets you. If you pause the video now, you can check back to see if you've got the right answer. Alright, so you probably have figured out that you have your horizon, your flash, and then the minutes. So here's my minutes again, here's my flash, and there's my horizon. And you might have noticed that at 480 minutes, the flash was $78.50, while horizons was $78. So right there is where we would say that they would break even. Now, obviously the flash was a little bit more than the horizon, so you could actually figure out per minute what the exact break-even point is, but for this example we're just going to pull it at 480. So 480 minutes, that's your break-even point. So if you wanted to send less than 450, you would probably want to go with the horizon cellular plan, but if you had more than 480 texts, you would want to go with the flash player. Alright, well, let's take a look at some of these other additional examples from 4.4. I wonder if I can, nope, I guess I can't get rid of that guy. There it goes. Okay, so we're going to take a look at the rest of these examples here as we are going through. And we are going to start with this one, 7a plus 2 is the same value as 42 minus 3a. Okay, when you have variables on both sides, we have two variables. One of them is on this side and the other one's on this side. When we make our equal sides here, I always tell students to make your variable positive. So if I were to subtract 7a from this side, I would also have to subtract 7a from this side, resulting in a negative a number, which is fine, you can do that, but when we end, it's going to be a lot easier if you go for that positive value. So what I'm going to do is I'm going to add 3a to each side, and I have 10a plus 2 is the same as 42. And then I can just keep solving it just regular. So minus 2, 10a is the same as 40, and divided by 10, and I'm going to have a equals 4. Now, I should probably go back and check to make sure that those are correct. So a equaling 4, I want to know if that's correct, so I'm just going to erase this bottom part down here and see if we have the same value, if I get a equaling 4. So here we go. We've got 7 times my 4 plus 2 and 42 minus 3 times 4. So 7 times 4, we've got 28 plus 2, and then 42 minus 12. And then, yeah, looks like it's going well, 30 and 30. Perfect. So I know that 4 is correct. Now, a couple of things for your homework. Number 1, show step by step. So 1 step per line. And then the other thing that you've been noticing in this example is that I've been writing down. So go ahead and turn your paper over and let's try another one. Or if you want to review that one, you can go ahead and review the video or all those different things that you could do. So it's a pretty sweet deal when you're on a video. You can just do what you got to do to get that lesson figured out. Okay, so let's take a look at this next one. We have 21x, that's bad for 21, minus 9 is going to be equal to 11x minus 39. So again, I'm going to look to see, this side I've got 21x and an 11x. So which side am I going to move my x's to make it a positive? If I subtract 11 from this side and 11 from this side, I'm going to end up with that positive x on the left-hand side. So I'm going to do that, and I get, again, 10x minus 9 equals negative 39. That 10x likes to show up in these examples. And then I just move my all of my like terms together. 10x equaling, and then a negative 39 and a positive 9 would be negative 30. Dividing it by 10, I get x equals a negative 3. Well, let's see again. We always want to check to see if we're right, because in algebra you always can turn your test in, your quizzes in, your homework in, knowing whether or not you were right just by checking your work. So again, let me just erase the bottom part here. I'm going to keep my x equals 3 to kind of help remind me of what we're doing. And then we're going to do 21 times negative 3 minus 9. 11 times negative 3 minus 39. This is kind of intense. All right, so we've got a negative 21 times a 3, which is a negative 63 minus 9, and a negative 33 minus 39. And let's see, it's looking pretty good right here. We got negative 72 and a negative 72. So again, we're going to combine our x's or our variables to one side of the equation. Combine all of the other like terms on the other side, all the ones on the other side, and then we just solve for that variable. All right, let's try the next one on your paper. And if I can just erase all these little tick marks everywhere, I tell you, I like it for a lean sheet. Okay, the next one we have is negative 13 minus, and then we have a group of something, x minus 2. And then that's going to be the same of negative 3 groups of x minus 3. So this is kind of a cool one. We've got negative 13, subtracting a group of x minus 2. And then that's going to be the same as negative 3 groups of x minus 3. Okay, so the first thing we have to do with this problem before we can even start combining all these different terms is distribute our negative and our negative 3. And the reason that we do that is because we want to make sure that we know exactly what we're adding and subtracting. For example, I could add an x minus a 2 here, add an x minus 2, but there's no like term on this side to connect it to. So in order to make that happen, I need to first distribute out that negative sign. So I've got negative 13, and then I've got the opposite groups of this. So it's going to be turned into an opposite x, and then a positive 2, and that's going to be the same as I've got negative 3 groups of this, so it's going to be negative 3 x's, and then negative 3 groups of a negative 3 is a positive 9. And here, again, I'm back to where my other example started. So I'm looking at my x's. I've got negative 3x and a negative x. So what I think I might do is add 3x, because then I can get a positive value for that x. So I might also combine my negative 13 and my positive 2 to get a negative 11 plus 2x equals, this is all gone here, that looks like a division sign now, plus the 9. And then I can add my 11, add 11, and I've got 2x is the same as 9 and 11, which would be 20. And then make that x a little bit more, divide it by my 2, and I have x equaling 10. That 10 just shows up all over the place. All right, and again, because I'm in algebra and because I can always check my work, I always know whether or not my solution will work as long as I follow the rules of algebra. Let's get this erased here. All right, so we have negative 13 minus a 10 minus 2 equaling negative 3 times 10 minus 3. Okay, 10 minus 2 is an 8, so I've got a negative 13 minus an 8, and I've got a negative 30 minus a 9. Okay, wait a second, that's not what I wanted to do. Goodness gracious. I want to do negative 3 groups of 10 minus 3 would be 7. So now I've got a negative 21 on this side, and again a negative 21 on that side. Pretty awesome. Love this stuff. All right, last example, guys, and then you guys can get going on your practice problems. I can get this erased here. Again, feel free to pause the video anytime you need to, or even fast forward it as I'm erasing. There should be a way to just make a new thing here. Okay, I'm sure there is. I just don't know what it is. The last one is my favorite problem, and I'm going to go through a couple steps with you guys to make sure that it makes sense. So if you need to read it, go for it, pause the video, and read through the problem. If you've read through the problem, you know that we've got a rectangle and a triangle. So over here, I'm going to draw this rectangle, and then I'm also going to draw this triangle. And we're working with perimeters. So we know that one side of the rectangle is going to be an x plus a 4. So I'm going to put x plus 4, and then the other side of the triangle, or excuse me, the other side of the rectangle is x minus 3. And then we know our perimeter of our triangle is an x and an x plus a 6. So if I was really good, I would totally make that a little bit longer, but we're just going to use it as a sketch. Okay, it says that the perimeters will both be equal. So when we're dealing with perimeters, we want to make sure that they're going to be set equal to each other. So the perimeter of this guy right here is equal to this one. All right, so when I add the perimeter of my triangle, we can do the triangle on this side. This might be easier. We'll have an x plus an x plus x plus 6. We're just adding all the sides together. Now for the rectangle, it's a little bit trickier because I need 2 of these sides. So I'm going to actually use my distributive property of 2 groups of x plus 4. And then I'm going to add that with 2 groups of x minus 3. All right, so now it's just combining like terms, solving for my x. I've got 3 x's on this side plus 6. And then I've got 2x plus 8 plus 2x minus 6. And I'm going to keep my 3x plus 6 over here. Combine all my x's, 4 x's, combine my 1's, plus a 2. All right, now again, I'm going to look for my x's to see which side I can keep it positive. So minus 3x on both sides. I've got a 6 equals x plus 2, and then I just subtract my 2. And I get 4 is the same as x. All right, now what I can do is I can check to see, I can plug those values in. So this would be an 8, this would be a 1. Oh, that's not a very good rectangle. I should have swapped those two. And then this side would be 4, this side would be 4, 4, and then obviously this one would be 10. All right, you guys, so it's a pretty sweet deal. Your solving variables on both sides opens a lot of different doors. The biggest thing is that I can tell you is to keep your variable positive on one side. Good luck on your practice problems.